lecture number 1. And then this lecture is about engineering economic decisions. Which kind of economic decisions we take in engineering life? So we have been talking about our private life, our personal lives, of saving money for our future, for our pension, for our kids, and trying to get some return from our savings. So now we are living that individual sphere of our lives, and we are going to talk about our professional life in terms of engineering economic decision. Which kind of engineering decisions make the engineers? So let's go to the lecture number 1, page 2. This is the typical workflow of our job. The kind of situations, the decisions of engineering economics are already present. We make plans. Is the first kind of things an engineer does is planning. Planning in terms of technical performance of the system, planning in terms of the detailed design, and planning also the economics of the project. If our company will earn or not money from that investment, from that project. After that, we execute the project, we invest. Our company take the money and buy assets, pay people and suppliers, and invest the money and creates new manufacturing facilities, or in the case of services, provide or start to deliver new services, like for example a fiber optic network, or in the case of delivering services, or in the case of products, of goods, it can be manufacturing of a car, of a new facility, of a new plant, car production plant. When we have delivered our services and manufactured our products, is the time of marketing, of trading, of selling those products, those goods, those services. Is the moment, is the right time to market, to go to the market and sell them. And then after that, our company will get profits. And if the market or the product or the project was not fully or adequately planned, or it was so costly and the price is not good for consumer, our company will get losses, will incur in losses. So what is desirable for our company is to obtain profits. So that is the full engineering economics range of different decisions we can take in planning and in the phase of investment, and even in the manufacturing, because we are going to calculate or to estimate the cost of products. Let's go to the next slide, is the number 3. What we're going to see now from this point is different slides from an example, a case, a business case. I have selected that case representing the case of Shell. You know Shell because when you need fuel for your car or diesel for your car, you go to a petrol station, to a fuel station, and then you get your fuel or your diesel, your car. And how is the business of Shell? We can say that Shell is an industrial firm. Why is an industrial firm? Okay, probably it's difficult to define that Shell is an industrial company or firm, but I say that Shell is an industrial firm because it has, in that case of Shell, they produce raw materials. Which kind of raw materials produce Shell? They produce oil and gas. So that is the upstream business of Shell. They call upstream because it's in the upper part of the stream, of the business stream. What is the upstream of Shell? They explore different fields, and they deploy wells of oil and gas. They call fields. So at the end, they produce oil and gas. In that sense, they are an industrial firm. An industrial firm is characterized because they produce goods. What they do then with this raw material, oil and gas? They need to prepare to manufacture those raw material to prepare for going to the final consumer of these raw materials, and they process this raw material through these different kind of technologies and facilities, and at the end we have final products. What are the final products? Is the retail sales, when we go to a petrol station, fuels and lubricants, chemical products for plastics, coatings, detergents, so many things we use in our lives come from oil and gas. That's the reason it's so important, oil and gas, for our society, and also for cooking, heating, the gas. So that those facilities of liquefying gas by cooling, LNG, converting gas to liquid products, GTL, producing petrochemicals, what we call the different refineries, refining. We see several of them in Spain. So this is an industrial company. What happened is that when we buy a liter of fuel, is the result of industrial transformation, several facilities which transform, and the result of exploring. Exploring, you make a hole in the earth because you guess that in that point there is some oil or some gas. So explore. Sometimes you succeed, or sometimes you fail. But in any case of them, you have spent money in that exploring activity, and then you find a field. You find a bag of oil or a bag of gas inside the earth, and then you need to create a big infrastructure for extracting that oil and that gas. What we call the producing oil and gas facilities, like the wells or like offshore platforms, some very big structures, quite expensive, and you need a lot of time to develop them. I'm talking about 5, 6, or 7 years, and you need a lot of permits, of regulation in terms of environmental regulation, governmental authorization. So big projects, lot of money, lot of time to develop, and then at the end you have you start to produce and to extract oil and gas, and then you need another facilities which are big also. I don't know if you have seen a refinery. For example, if you go through the Tarragona coast, near to Tarragona, in the middle of Tarragona city, I mean in the surrounding area, you see the Tarragona refinery of Repsol is a big one, or in San Roque, for example, in Cádiz, or in Portollano in Ciudad Real, in the center of Spain, and this is a big facility. It's lot of square meters, lot of pipes and sophisticated technologies and machines. And again, we are facing the same environment. We are seeing a lot of money, lot of time to develop the project, lot of administration permits, lot of environment studies to diminish or to reduce or to avoid environment harm. And then we have the downstream business. The upstream is the refineries and this part, the exploring activities and the extracting activities. And then the downstream, at the end, we have distribution points. We have the fuel, the petrol stations where we go to buy the fuel. And at the end, this petrol we pay in Spain, many countries also. We pay a lot of money. I think this morning I read in the news that the petrol is, the fuel. The fuel is 1.5 euros. A lot of money. About 40% of that 1.5 euros are taxes. Taxes paid by us to the government in terms of value-added tax and in terms of different government taxes. What is the cost of a liter of fuel? Probably will be 60 cents euros. And the rest, more, perhaps 80 cents euros. And the rest, is to 1.5 is taxes. What is the cost? Why the cost of this fuel is 80 cent euros? Because the company, in that case, Shell, have to charge all, in that liter we pay, all the investment they have made in the extraction and the exploring business, the extraction phase, the refinery, and the different parts of the production. And at the end, the cost of that activity, of those activities, are 80 cent euros. So that's the reason. And then, as we see, the title of this slide is Shell and Industrial Firm investing in productive assets. Asset is those facilities, no? Investing in productive assets with intensive engineering. So lot of engineers work here, lot, and they design, they calculate not only technical performance, but also they plan and they calculate the financial return of those investments and the cost. What we see in the slide number 4 is different Shell data, Shell at a glance. Shell is a global group of energy and petrochemical companies. It is based on Netherlands and UK. It's the result of a merger of two companies, one from Netherlands, another one from UK. What is their strategy? They say our strategy, Shell's strategy, is to generate profitable growth. Look, please, that's the main target of this company. Profitable growth. It means growth. They generate every year new revenues. They don't stop generating revenues because they need to pay previous huge investments, and they need to pay a lot of wages and salaries of their engineers and technicals and so on. So they need to have growth, but that growth must be profitable, which means that from each euro they have spent, they need to have more than 1 euro as coming from revenues. For example, 1.2 euros. It means that they have a return of 1.2 minus 1 euro as the cost. They have a revenue, a gross profit of 20 euros, 0.2 euros. Where does this profitable growth come from? this profitable growth come? From investment program. That's the key message of engineering economics course, that the investment are strongly related with the companies we work as engineer. Investment is the main activity of those companies. Why do they generate profitable growth, and why do they invest in assets? As the next part of the strategy of Shell says, to provide competitive returns to shareholders is the main, of course, the main target of them is paying their workers and their suppliers, of course. And then when all this money has been spent and paid to suppliers, to employees, and then the rest of the money is devoted, part of it, this return to the shareholders, the owners of the company. You and me, we have shares of Shell. You can buy shares of Shell in the London Stock Exchange market. You can buy a share, and then when Shell decide to pay 10 €, per share as dividend, you will receive from your share 10 €, from your share. What is their target is to help their business is to meet global energy demand. What does it mean? That their business, the Shell's business, is to supply energy to the people, to supply energy to the demand. Lot of demand of energy. We need fuel, we need diesel, we need natural gas. We need a lot of our electricity we use comes from natural gas plants, electricity generating power plants that they use as an input natural gas, or even the case of diesel or fuel. And they describe their business in three different parts. We have talked about them: upstream, the exploring activity, and downstream, refine, supplies, trades, and ships crude worldwide. Okay, and they have, of course, the engineers' work is the project and technology, and the delivery of projects and research and development activities. So we see a very quite interesting company for working in it. Different numbers of Shell. They work in more than 80 countries. They give work or jobs for more than 90,000 number of employees. 48% of their production is natural gas. The other is oil. Big, huge figure of the number of million tons of liquid gas they use. They produce is 18.8 million tons. A lot of money, suppose. They produce 3.2 million barrels of gas and oil every day. It's a lot of barrel. A barrel of gas and oil is, we can see the typical public works barrels of this kind of cylinder, no? I'm talking about. It is about 140 liters of oil. One barrel is 140 liters. They have 43,000 Shell service stations worldwide, more than 30 refineries and chemical plants. So we have a clear view that this is a big company. What are their revenues? The revenues of Shell are $470 billion. $470 billion. How much is the revenue of the biggest company in Spain, or one of the biggest companies in Spain is Telefónica. You know, Telefónica is worldwide, making business worldwide, many countries, and their revenues are about 70,000 euros. So Shell is one of the biggest companies in the world. Their income, the income is their profits are 31. So less than 10% of the revenues is the return they obtain, the profit. How much money they invest every year? A big amount, 31,000 billion. You know the billion, American billions are the thousand of million of in Europe, thousand of millions. So this is 31 thousands of millions in European. This is a big amount. How much money Telefónica invests in the world every year? Like 8,000 millions. So this is 31,000 million is close to 4 times. They invest in research and development 1.1 billion. So we see here that the main driver of their business, of that kind of companies, of engineering companies or engineering-based companies, invest a lot of money to generate future revenues in enough amount to generate profits. So that's the idea, to invest a lot of money for future revenues that generates incomes for the shareholders of the company. We have here some figures about the future they are planning. You can read. I let you the reading of that. And as an important fact is they say for the next future, the next outlook of from the 2012-2015 is our options for future projects means that we are more constrained by limits on capital than by limits on opportunity. What does it mean? Let me explain. They say, okay, I have 30,000 millions euros per year to invest. How many investment opportunities I have? What are the different projects I'm studying, I'm evaluating, I'm assessing this year? How much are they worth? They say, for example, 50,000 million euros. So the opportunities are 50,000 millions. They say, we don't have that money to invest. We have many opportunities, but we don't have enough money to invest in those opportunities. So our capital, because our capital is lower, is less than the needed to afford those projects. So we have 30,000 millions euros. So they are restrained, they are constrained by capital, as they say. That's an important idea. So they have to prioritize the most attractive opportunities. So what I ask you, students of engineering economics, which kind of methodology will you use to prioritize investment opportunities to find the most attractive to your bosses, to your shareholders, to your president, to your CEO? Which kind of methodology? That's the kind of methodologies we are going to learn in the course. Our company have business opportunity, investment opportunities. Our capital is constrained, is less than the business opportunities. So we need to select the projects, the investment projects, according to some rules, some methodologies that create a list, an ordered list, from the first or the most attractive project to the least attractive project. What are those methodologies? Engineering economics methodologies, the ones we are going to learn. So I want to with these slides to put to say you that this is quite important for companies. The capital allocation task, to decide where to allocate the capital of the company. Okay, you have here several economic numbers from Shell, the earnings, the total shareholder return, the production growth. So that is the projected needed production. In the year 2017, they plan to have 4 million barrels of oil. BOE, it means billion of equivalent oil barrels. Barrel is this cylinder I have talked before about 140 liters of oil. So they want to produce 4 million barrels every day. How much is the current production in the 2011? Is like 3.2. So if you estimate, you calculate the increase from the 2011 to the 2017 in 6 years, they need to increase their production in a 25%. How are they going to increase that capacity of production? Of course, investing in new facilities, evaluating different investment projects. How are they going to increase their cash flow? Of course, with new business or with new investment opportunities. Let's have a look to, for me, it's quite marvelous, or it's big project. One of the most big engineering project, the bigger engineering projects in the world today is the one deployed by Shell, which is the Australia, is going to be developed in the Australian coast, in the northeast of Australia, 400 kilometers from the shore, from the coast, which is is 400 in the middle of the ocean, the Pacific, the Indic Ocean, and they are developing this huge facility. We are going to see what is this facility. This facility is on the sea, is floating. This is liquefaction factory. You know, under the sea, on this region, there is a lot of natural gas. The problem to extract that natural gas is that you need here physical facilities to go under the sea, 200 or 300 under the sea, and then drilling also the submarine earth, another 200 or 300 meters. So, and then putting them pipes in that subaquatic earth, and then another 200 or 300 meters on the sea, and having here on this plant, on this factory, the natural gas which has been extracted from the field. What's the problem with that natural gas is that we are 400 kilometers away from the coast, from the shore. So how do you transport 400 kilometers from the coast this natural gas? This is a challenge, engineering challenge. What they have decided after many years studying the problem is that they are going to design and to deploy and to construct a facility, a floating facility, like a big ship, which is floating on the sea. You will say, why is not fixed on the sea? Obviously, if you want to fix on 200 or 300 deep waters, you need 200 or 300 columns or something like that to fix the structure to the submarine ground. And this is impossible to construct. So the only solution is to have a floating facility. The problem with a floating facility is that this is moving, is that the huge amount of natural gas they have found under the sea, they need a big factory to extract that petrol, that natural gas. And the second problem that appears is what do you, when you have the gas, natural gas extracted, how do you distribute to the final consumption points, our house? So the problem is that perhaps some big ships can arrive to this facility, connect their pipes from the ship, from the transport ship, to the facility, to the natural gas facility, and connecting those ships with the facility and moving the gas from the main facility to the ship. What happened is that you cannot transport the gas as a gas. The natural gas you have to transport in a liquid way. Why? Because if you want to transport the natural gas in a gas way, this is quite inefficient, and you will need big ships, or instead of it, lot of ships with the same capacity. What about to liquefy that gas, that natural gas, to convert from gas to liquid? That's the role of this facility, is that they not only extract gas, but also they process the gas, they convert from gas, they convert to liquid. And this is the number of the facility, which is floating liquid natural gas. So that is the Shell Prelude project. That are this is the context. I have explained it. You can read later. And you will see that the shrinking volume you can get from shrinking the natural gas in gas, converting it to liquid, you will reduce the volume in 600 times lower. What you have to do to shrink that natural gas from gas to liquid? You need to freeze, to chill the natural gas to minus 162 degrees. Quite cold, no? Yes, it's quite cold. So you need a lot of machinery to produce that chill temperature. So that is the challenge of this structure, which is floating, because we have explained why, is far away from the coast, far away from the shore. So you need to transport, to get out from the facility, to convert into liquid. So you need technology for chilling the natural gas to minus 162 Celsius degrees. So that's an big industrial infrastructure. Something like that. Some numbers. 848 meters long, 74 meters wide. What does it mean in practical terms? 4 soccer fields from end to end. So a soccer field is like 110 meters and something like 60 meters wide. So we have 4 soccer fields like Santiago de Bernabéu or Camp Nou in Barcelona, or it's a big 4, one after the following. The displacement of water they move is a lot, and 400 kilometers is the facility's distance from the nearest land. The water depth of the field is 250, as I have said. The height over the earth, over the water surface, the height is 100 meters. So it's a big. They are prepared to suffer 280 kilometers per hour winds, cyclones. You know, this is the Indian Ocean. You know, it's tropical region and lot of cyclones and hurricanes. So it's ready to support, to be able to. And then you see here a picture of the kind of cables and flexible cables and pipes. You see here the different wells. They are extracting the natural gas, the wells, and this is the full set of them. The wells is the field, the natural gas field. You see here different figures. How much they are investing in this project? They say we are investing different figures. I believe in that from Financial Times. 11,000 billions dollars. It's a lot of money. 11,000 billions. Those are the number of engineers working, 600 engineers, lot of different machinery, 6,700 horsepower of the 3 thrusters. You can find what is a thruster. Lot of big figures. And you see here the project. They discovered the field in 2007. We don't know when they started to find, but they discovered the field, the gas natural field, in 2007, and they prepared to hire the consultants and the engineers and the construction company to design and build the facility, what we call the request for proposal. This is a document that you send to potential engineering companies and suppliers, and they send you a technical and economical offer. They spend 2 years, and then they need a lot of government approval process of environment and so on. They decide during 2 years, in the 2010, 2011, the investment decision using the economic engineering and economic techniques, and then they are executing the project for 5 or 4 years, and in 10 years after they discovered the field, they are going to produce for 25 years, I think, from the 17 to the 14th, 25 years. So that's the kind of planning we have to do. That's cash flows, investment cash flows, spending cash flows, production cash flows. How much are they worth today? Have we to go sell? Has to be to invest in that new plant or not? Does the investment comply with the expected return that the shareholders have as a goal? That's the kind of question we are going to explain in the project, in the engineering. You have here several data, and let me finish for today with the VP, vice president of Shell, the upstream, which is the person responsible of all the upstream, when they started the civil work in 2011, he gave a speech entitled "Starting a Revolution." We cannot discuss that this is a revolution. The decision to build a floating liquefied natural gas facility. Ladies and gentlemen, I am an engineer at heart. This man can be one of you 20 years later. I am an engineer at heart, so forgive me if I get excited about this spectacular technology. You are seeing me, you are watching me, quite excited about this project. And he said, also, I am an engineer and I'm excited. But this is not the most important. Engineering is a media. It's a way. This project is an engineer's dream. But ultimately, the process will serve only for a single purpose, to bring more gas successfully to market. So don't forget that this project is planned and developed and invested for the Shell company to deliver, to bring more gas to the market. So we have invested much time and effort to get to today. So that's I think it is a good summary of the lecture and a first starting point to learn detailed calculation that we will going to see tomorrow. So I think we have here some slide. We will start in the next day with those. Okay, I think we'll be quick. So thank you very much. Have you got any question? I don't want to spend more than any question. Ignacio, Alejandra, I see you are here. Or if not, then thank you very much for your attendance. I hope to see you tomorrow. I know some of you have some problems with to comply with the calendar, the schedule, but it's the only timetable I have scheduled free for me. So I hope you can. The people who have seen been watching the lecture through the remote lecture and the deferred, I mean the recorded. Also have a nice evening and see you tomorrow. Bye bye. Is the decision to build a floating liquefied natural gas facility, the FLNG facility. This speech was given by Malcolm Branded, which is the executive director for upstream business of Shell, during the act of starting the works for developing the facility. Ladies and gentlemen, I am an engineer at heart, so forgive me if I get excited about this spectacular technology. So this project is an engineer dream, so we agree with that this is a big project. We, like Malcolm, we are quite excited about this kind of project because we can find there a lot of work, a lot of professional opportunities, and a lot of technology. But as Malcolm says, this project only serves for a single purpose, which is to provide gas, natural gas, to provide to the market. So projects, engineering projects, are all of them oriented to satisfy market needs. So this is important because the profitability, the returns of an engineering project, economical returns, depends on the successfulness of this project in the market. And he said, we have invested much time and effort to get to today. So it's a lot of time and money they are investing in that project. So what we have learned from this experience, from Shell experience, is that, as I have said before, engineering work increased the wealth of employees, not only direct employees, but also contractors and, in general, the population, because they demand natural gas, and we need that kind of project to increase or to improve the development, the human development. So what is another point from this experience is that this is a multi-billion investment. We are investing, or they are investing, in long life assets. So those assets are not for 1 year of life, or for 2 years, or 5 years. I think the Shell facility life expectancy can be about 25 or 30 years. So they are investing a lot of money for a long life return. What do a business, a company, a firm expect from this kind of project? To obtain, to generate huge and positive cash flows. What is a cash flow? It's the money that gets into a company, coming from customers, and what does the company do with that money? Is to pay all the expenses, reinvesting them. Part of those cash flows are needed to reinvest in the business, because the next facility must be developed, because for the next 10 years from now, this company needs to have a future investment and future capacity to produce the future demand of natural gas. And of course, it's not only a matter of paying expenses and reinvesting in new facility, but also paying the investors, the shareholders of this company. They invest in that company, they buy their stock, because they expect to have some return. They expect big returns, of course. Our role as engineers, I think the most important lecture we have learned from this experience is that there are lots of engineers working there, of course, highly qualified, offering creative and innovative solutions to the practical problems of putting a production facility at 400 kilometers from the shore. And of course, in terms of personal and professional development, those engineers are quite motivated, I hope, creating sound investment proposal, designing and executing and obtaining good returns for their companies. So I think this is the main surrounding scenario we can talk about our work in the field of engineering economics. So, and then we can define what are the kind of decisions we can make in engineering economics, and the role of engineers in those capital investments. The decision of taken in the engineering economics are related with the evaluation of engineering projects based on the merits of economic desirability. So we have to find different methodologies to measure that economic desirability for our company and for this project. No? What is the role of engineers in making such business decisions? Which methodologies, tools, and techniques do we have to make such investment decisions? So that's the role of engineering economics. Part of the task of our task will be to forecast volume of sales, prices, and cost. And a typical role of an engineer is thinking about the future. So the future is one of our main horizons we have to work, is the long range of our decision. And then we have to think about the future. For example, in the case of estimating what is the required investment for a new network or a new system or a new facility, how much our company have to invest. Also, we think in future when we forecast the product demand. So we are developing natural gas facilities. So what will be the demand of natural gas in the Pacific Asia region that justify in terms of revenues that investment in the facility. No? Another one is to know the cost. What are the costs of manufacturing or the manufacturing cost? So we have to decide about not only about the investment, which is we do today, but also we have to think what would be in future when the new facility is ready to produce. What will be the cost of producing things in that new facility? That cost will include, of course, the investment cost, but also production cost in workforce, in external providers, in terms of electricity consumption or other raw materials we need. So that is an engineer's role. And of course, estimating the product life, no? What will be the product life. And then we can have a general view of the role of engineers in business. As this slide tells us, we participate in creating and designing engineering projects. We analyze from the point of view of technical assessment, the production methodology, the production methods, engineering safety, environmental impacts, or market assessment of the new project. And also we evaluate not only technical analysis, but also we evaluate the expected profitability, the timing of cash flow, and the degree of financial risk. This is the main task of engineering economics. This is technical engineering, and this is economical engineering. And then, of course, when the project starts, we have to monitor as project managers or project leaders. We have to monitor the impact of this project in the financial statement of the company, on the market value, or even in big projects, the stock price, the price where when you buy a share of this company in a market, and then this is the stock price. So it's a big, different kind of activities is the role of engineers in business. We can, this is a general flow chart of the rational decision-making process an engineer have to follow. The first one is we are thinking about how to make a decision about a problem, no? So we have to understand the problem, is to recognize the problem. We need to identify, to define what is the goal or objective. We want to solve this problem with that objective, and then we need to join, to find, to look for different data, to decide, and then we have to plan, to identify different alternatives, all of them, of course, feasible. And then we need to select, to identify a criterion to determine what is the best alternative. So we have a problem, we define the goal or why we want to solve this problem, and then we have some data to decide. We identify several alternatives, and then we need a criterion to determine from those alternatives we have what is the best. And then we need to construct a model. A model for what? A model for deciding. For deciding which alternative is the best. And this model, our engineering economics model, we need to evaluate, to assess every opportunity, every alternative, to evaluate, to assess in terms of profitability. And what we'll be doing is to choose the best alternative, and then, of course, at the end, when this solution is already in course, then audit the result of the action. What is the different engineering activities that engineers are presented in the companies? For example, one big issue for companies and for the engineers working in those companies is making decisions on the investment. How do the companies name, what is the name for the companies, what is the name of investment? They call them, this word, capital expenditures. What is capital expenditure? Expenditure, you know, is expense, but they say this kind of expense is not a consumption, like paper or something like that you consume and then it disappears. No. Capital, we are talking about capital. We are talking about assets that are deployed and then are used during a long life. If you produce, is because you have invested in those capital expenditure, those capital assets. So that's a role of engineers. That is an engineer's role to decide, to make capital expenditure decisions. No? Engineering decisions account for the majority of cost of production. We have to consider the capacity or the effective use of fixed capital assets of our company, like buildings, machinery, facilities, networks or mines, etc. And we need to estimate the cash flows and the benefits of the fixed assets during the service life. So we are investing in CapEx, in assets with a certain level of CapEx, and then those assets will produce cash flows. And then we have to estimate what is the interest for our company to invest in those CapEx. And then what is the main problem we can have working as engineers in making such capital expenditure decision is that an accurate estimate of the assets capacity or under or over capacity can provoke serious consequences for our company. So if we decide to invest in a network and the network at the end, 2 years from now, doesn't have enough capacity for the customers' demands on voice or data mobile services, that network will be congested in 2 years. And we, as engineers, we decided that the network capacity today for the next 2 days, for the next 2 years, was that. And then we incurred, we failed in our estimation. So our company has invested a lot of money during these 2 years, and then we are provoking serious consequences. No? Also, in large-scale engineering economic decisions, like we are talking about large-scale investment, our work is not only going to the detailed engineering product design, because we decide about the economical side of this project. No? Also, we see that the engineering projects also have an impact on the financial statement of the companies, on the balance sheet or the earnings of the company and so on. So it's an important thing for companies. For example, it's quite important for companies to set up a hurdle rate. What is a hurdle rate? Is the minimum rate, the minimum return a company set up for approving projects. So if that project you are presenting to the committee, its return is lower than, say, for example, 10%, we will not approve that project. That rate, the minimum return, is the hurdle rate. It appears here. So this is corporate policy to decide what is the minimum return rate that a project would need to, would have to in this project, and then to approve. If not, we will not approve that project. What is the difference between accounting and engineering economics? I think it's clear for everybody. Accounting, it matters on the records of economic information of the company, but they don't worry about the future. They are mainly worried about the past, trying to register every economic transaction in the company. That's the accounting. They don't think in future. Who thinks in future in the company for the cash flows, the future cash flow? The engineering economics discipline, and of course, I'm talking about engineering-based company. So the engineers prepare plans in the present to create assets, and in the future to produce future cash flows. So that's the role of engineering economics, and this is not an accounting task. So that justify the presence of engineers in those decisions, economic decisions. Different of strategic engineering economic decisions we have seen before. For example, the new products or product expansion, equipment and process selection, cost reduction projects, equipment replacement projects, service or quality improvements. So all of these kind of activities are led by an engineer, and all of them have economic consequences. For example, when we decide, or our company make us responsible of the new product, of a new product, we have to think about this new product, to design it, detailed design, technical detail, technical engineering, and so on. But also we need, we will be responsible of knowing the economics of the new project, of new product, the investment we have to do, our company have to do, the cost of production and the revenues which are expected to have this project. Also, we need to take into account engineering economics when we are selecting an equipment. For example, this equipment is cheaper than this other, but the maintenance costs are higher. So we need a criteria, an economical criterion, to decide if this equipment which is cheaper today, but its operation and maintenance costs are higher in the future. So we need to decide to have a certain methodology to decide. Project of cost reduction. So if we substitute this old machine which costs that amount every month, what will be the economical impact of buying a new one? That it will be the role of the equipment replacement. And then we need to make some economic calculation, and that's our target in this course, no? Even also in the case of service or quality improvement. We are going now to see the main principles of engineering economics, but I think it's important to remember that the main factor we face in engineering economic decisions, which define all the aspects of any decision, engineering economicus, is time. So time is the most important thing, because a company invests in assets that they will generate returns along or over a certain time, the lifetime expectancy of this asset. So time is important. How many years will be producing that new network, that new facility? And the other one is uncertainties. We don't know what is the cost of, we try to know the cost, and we don't know the revenues. So this is uncertain. So time and uncertainty creates the concept of risk. Risk is something that we don't like, and risk is related with time, what will happen next day, next week, next year. And uncertainty is also what is something that we don't like. We will have revenues, we will have certain level of revenues to recover the investment or not. So I don't know if you hear the demonstration. I think perhaps you can hear, they are outside, so I hope not interrupt our lecture. I'm going to see if there are some chat or not. Any question? No? Okay. So I see here Ignacio. Okay. Let's go to next slide, number 27. This is quite important. This is the end of this lecture. The 4 fundamental principles of engineering economics. The principle 1 is that $1 today, one nervy dollar, today or tomorrow, is worth more than a distant dollar. What does it mean? If I ask you, Ignacio, you will say, I say you, Ignacio, do you prefer today $1, or do you prefer in a year? I will talk about higher figures. Do you prefer now $1,000 today, or do you prefer $1,050 in 1 year? So probably you will say, I prefer today your $1,000. So this is an important, because we don't like risk. You will say, oh, what happened if in 1 year you will not come back or don't give back? You will not give me the 1,050 euros. That's the risk. So you prefer to receive today. The principle number 2 is that when you have several alternatives to decide from the point of view of economics, you only have to take into account the difference between the cost or the revenues, difference between both alternatives or the several alternatives. It means that if all of them have the same cost or common cost, that will not, those common costs, they will not explain the difference between the different alternatives. What is characteristic of each alternative is its costs and its revenues. So what I'm going to use are the difference among alternatives, to compare different alternatives. Principal trace is the marginal revenue. We are going to see now what is marginal revenue must exceed the marginal cost. We will see now. And the principle number 4 is additional risk. So if I take an additional risk from another alternative, I will do in the case that the expected return will be higher. So additional risk is not taken without the expected additional return. Does it mean? What does it mean is that, Ignacio, in your case, I promised giving you in a year 1,050 euros. But if you want, I can give you 1,200 euros. But will you say, what's the difference between having tomorrow, in the next year, 1,050 euros or 1,200 euros? What's the difference, Luis? I will say that is risky, the second alternative. I'm not sure if I will be able to return your money, your 1,200 euros. So you have higher return, but you have higher risk. So this is a basic principle in investment theory. So the first one is a nearby dollar is worth more than a distant dollar. So we prefer to have a dollar today than to have this dollar or a bit more of this dollar in the future. We prefer we want to be sure that we have today 1 euro. What could happen with our euro in the future, we don't know. We are unsure about that. Second one is that all it counts is the difference among alternatives. So we have two options to buy a car, for example, and the option of buying a car or the option of leasing a car. What's the difference in terms of cost? For example, we see a table here with 1, 2, 3, 4, 5 columns. The first, or 6, including the first one. The second and the third column, the monthly fuel cost and the monthly maintenance, you see that the option of buying, the fuel cost is the same. 960 euros, because it's the same car. The monthly maintenance is similar, is the same. It's 550 euros, which include insurance or future repairs or so on. So, but what is different is that when I buy the car, when I get the car, in the option of buying, I have to pay 6,500 euros. This is the cash outlay. This is the cash leaving from my pocket, the cash outlay at the moment of signing the contract. So if I buy the car, I will pay 6,500 euros. If I lease is like renting. You will not pay the car, you will not be the owner of the car, you pay like a rent, like a lease. So you will not pay the 6,500 euros, you will pay less. You will pay an entrance ticket, something like 2,400. And then the monthly payment, because you have a loan for buying your car, you pay every month for buying, the option of buying 350 euros. In the case of lease, you pay more, 550 euros. Why do you pay more? Because you have paid less in the case of leasing at the signing. You pay less at signing in the case of lease, in the option of lease, than in the case of buying. So, of course, what happens is that the monthly payment is higher in the case of leasing. And then there is another, at the end of year 3, then you want to have another car or to buy another one or not to have a car. And then this is the salvage value. What is the salvage value? Is the future value of this car if you want to buy, to sell this car. So you have a value of 9,000 in the buying option, but in the lease you cannot buy because you cannot sell because it's not your car, it's the insurance or the renting or the leasing company. So we have to decide we will not include in the decision-making process the red colored columns because they are irrelevant. Why they are irrelevant? Because they are equal. They have the same value. So in terms of economical evaluation, we don't worry about the common cost of alternatives. What is the principal 3 is the marginal revenue of the project. The marginal revenue of an alternative must exceed marginal cost. What is marginal concept? Also for revenue and also for cost. The concept of marginal in economy, it means the increase or the decrease, the increase in terms of revenue or the decrease in terms of, the increase in terms of, in both cases, in both cases increase. If we sell a new unit, we will increase our revenues in the price of the unit, and of course we will increase our cost in the cost of that unit. So this is the sales revenue, the green column, the sales revenue, and this is the accumulated one, and then I sell a new one unit of the imagine we are talking about cars, and not car, it's cheaper. We are selling, for example, tablets, computer tablets, no? And then selling a new one will generate an incremental revenue for my company of 250 euros, which is the price of one tablet. What is the cost of producing that new tablet? We have here in red column the manufacturing cost. We have accumulated all the cost of producing the previous 1 million or 2 million or 5 million units we have sold of tablets. And then if we sold the new one, our company increased its cost in 200 euros. That is the marginal cost. The total cost increase of producing a new one unit. So what this principle says is that to be this company profitable, the marginal revenue must be higher, must exceed the maximum marginal cost. It means that the price of the increase in revenues, of course, is the price, the unitary price, which is 250 euros, is higher than 200. So our company has a marginal profit of 50 euros. That is obvious, but this is a basic law in economy. And the other one is that the principle 4, additional risk is not taken without the expected additional return. So we have different investment opportunities in different assets, like for example, putting our money in a savings account. What is the potential risk? In general, it's low or none. There is no risk in putting your money in a cash. I mean, if you look for a bank with healthy accounts and with healthy financial situation, you will not have any risk. What does this bank offer to you for this saving account? A little. The expected return is 1.5%. You want to increase in higher risk, you have a moderate risk, you can buy Spanish bonds. You can go to buy Spanish debt from the Spanish government, the Spanish kingdom, and buying a bond, a 10 years bond from issued by the state, Spanish kingdom, the King of Spain at 4.8. So the expected return from the savings account alternative is quite higher. It's going from 1.5 to 4.8, something like about 3 times more. The risk is higher, so we have some risk of the government defaults or something like that. And if we want to obtain a higher return of, for example, 11.5%, we need to increase our risk. We will not to do without any cost. We have to increase, we will increase our risk buying the third opportunity, which is buying stocks in the stock market, buying equities. We have higher return but higher risk. So that direct relation between risk and return is direct. And this is important to remember, that if we are going to invest in a quite uncertain project, technological project, or environmentally project difficulties, or like for example the Prelude one is a quite uncertain thing. What are the investors requesting for that investment? Low returns. In the case of low or non-risk, do you think Prelude has low risk, moderate risk, or high risk? Because of that, the investor, the sales investor, will ask for a 1.5 return, or for 4.8, or for more than 10. What do you think? I think we have seen that this is a highly risk project. It's a high risk project, so our investor stockholder will ask for higher than 11, probably 15 or 20%. So that's the final of lecture 2, and we are going to start, lecture 1, and we are going to start in lecture number 2, time value of money. So have you got any question? Oh, thank you. 1,000, okay. Ignacio say, really? You prefer 1,000 euros in a year than today? Today I give you 1,000. Do you prefer to have today or in a year? Okay. In a year you cannot be able, okay. In that case, the risk is that in a year you will not be able to have that money. Sorry, I wanted to say in a year you cannot be able. Okay, so this is Ignatius. The important thing is that today I give you 1,000 euros, so you are sure to receive that 1,000 euros today. But I say, okay, I will give you 1,000 euros the next year, or 1,000 euros and a little bit more, 1,000 euros and 50. What do you prefer? What do you prefer? You will prefer probably to have today 1,000 euros, because you have today. You see today and you have today. And that has helped you? This. Okay. See you later then. Let's go to the lecture number 2.